Hello students, welcome to the lecture on scaling concept and its importance in business research studies. And after the lecture, we will be able to learn the following objectives. Describe the scaling techniques, describe the Thurstone scaling, explain the Likert scaling, define the reliability, discuss the processing of research data, explain the application of computers in processing and analysis of data. Let's start with a brief introduction to scaling concept and its importance in business research studies. Scaling is the branch of measurement that involves the construction of an instrument that associates qualitative constructs with quantitative metric units. Scaling evolved out of efforts in psychology and education to measure unmeasurable constructs like authoritarianism and self-esteem concepts. Meaning of scaling. Scaling describes the procedures of assigning numbers to various degrees of opinions, attitude, and other concepts. This can be done in two ways: making a judgment about some characteristic of an individual and then placing him directly on a scale that has been defined in terms of that characteristic, and constructing questionnaires in such a way that the score of individuals' responses assigns him a place on a scale. Let's move to the next topic, which is scaling techniques. The various types of scaling techniques used in research can be classified into two categories: comparative scales and non-comparative scales. Metric scale. Metric tools can only be used on metric parts. The metric scale or metric scales are measurements scales that are used in the metric system. The metric scale, unlike the American scale, has units based on multiples of 10. The advantage. One of the main advantages of the metric scale, it is considered easier to perform calculations with. The conversion of kilometers to meters, for instance, can be easily accomplished by just dividing the number by 1,000. On the other hand, in the American system, when it is needed to convert miles to feet, we have to divide by 5,280. Rating scale. All rating scales can be classified into one of the three classifications. Some data are measured at the ordinal level. Numbers indicate the relative position of items but not the magnitude of difference. Response options: strongly disagree, disagree, agree, strongly agree. Some data are measured at the interval level. Numbers indicate the magnitude of difference between items, but there is no absolute 0 point. Some data are measured at the ratio levels. Numbers indicate magnitude of difference and there is a fixed 0 point. More than one rating scale is required to measure an attitude or perception due to the requirement for statistical comparisons. Did you know the metric system became compulsory in France in 1840? By 1900, over 35 nations had adopted the metric system.
You've decided to create a survey, but what rating scale should you use? Sounds like a pretty simple question, but there's much to consider with all the variables involved. The key is to select the optimal scale for the project. For a live agent or web survey, we suggest a 1 to 10 point scale with 2 anchors. Using the 1 to 10 scales provides a more granular view, allowing you to produce more valuable analysis. A 1 to 10 scale is intuitive for respondents, as it's widely known. There is no middle score or midpoint in the scales where respondents can hide out. The 1 to 10 rating scale encourages respondents to give a score that truly reflects their experience, either positive or negative. We recommend using the same scale consistently throughout the survey. This minimizes confusion for the respondent and avoids muddying the results. There are exceptions, of course. If you're asking customers to enter scores by using a telephone keypad, a 1 to 5 scale is best. This offers less chance for the wrong button to be pushed, and easier for the customer too. The official rating scale for the Net Promoter Score is 0 to 10. Another exception. Ultimately, getting solid customer feedback is the goal, so choose a rating scale that's easy for respondents to follow and understand, and survey away.
Thurstone was one of the first and most productive scaling theorists. He actually invented 3 different methods for developing a one-dimensional scale: the method of equal appearing intervals, the method of successive intervals, and the method of paired comparisons. The method of equal appearing intervals. Developing the focus, the method of equal appearing intervals, starts like almost every other scaling method with a large set of statements. We cannot start with the set of statements, we have to first define the focus for the scale we are trying to develop. Let this be a warning to all of them. Methodologists often start descriptions with the first objective methodological step. Likert scaling. Likert scaling is a one-dimensional scaling method. Here we will explain the basic steps in developing a Likert or summative scale. Defining the focus. As in all scaling methods, the first step is to define what it is we are trying to measure. Because this is a unidimensional scaling method, it is assumed that the concept they want to measure is one-dimensional in nature. We might operationalize the definition as an instruction to the people who are going to create or generate the initial set of candidate items for our scale. Generating the items. We have to create the set of potential scale items. Rating the items. The next step is to have a group of judges rate the items. Usually we would use a 1 to 5 rating scale where strongly unfavorable to the concept, somewhat unfavorable to the concept, undecided, somewhat favorable to the concept, and strongly favorable to the concept. Selecting the items. The next step is to compute the intercorrelations between all pairs of items based on the ratings of the judges. Did you know in 1932 René Likert invented a measurement method called the Likert scale, often called a rating scale, which is used in questionnaires such as attitude surveys. Let's now talk about the reliability. Reliability has to do with the quantity of measurement. In its everyday sense, reliability is the consistency or repeatability of our measures. Before we can define reliability precisely, we have to lay the groundwork. First, we have to learn about the foundation of reliability, the true score theory of measurement, reliability and validity of measurements. We often think of reliability and validity as separate ideas, but in fact they are related to each other. Here we want to show two ways we can think about their relationship. One of my favorite metaphors for the relationship between reliability is that of the target. Think of the center of the target as the concept that we are trying to measure. Imagine that for each person they are measuring, we are taking a shot at the target. When we look at reliability and validity in this way, we see that rather than being distinct, they actually form a continuum. On one end is a situation where the concepts and methods of measurements are the same, reliability, and on the other side is the situation where concepts and methods of measurement are different, very discriminant validity.
We will specifically consider two ways of gauging the accuracy and error of our measures: reliability and validity. Reliability is the extent to which a measurement technique, applied repeatedly to the same unit of analysis, yields the same result. There are a variety of ways of assessing reliability that are discussed in the Johnson and Reynolds textbook. Rather than lay out all of these methods, we will focus on two in this presentation. The first is the test-retest method. The test-retest method entails measuring a phenomenon at 2 points in time for the same set of units, using the same technique at both points. Reliability increases as the difference between the values generated by the two measurements decreases. If I step onto a scale, measure my weight, step off the scale, and then step back on the scale, if I get the same weight, then the scale is a reliable way of measuring weight. If I want to know the party identification of each student in the course, I might ask each one of you to place yourself on a standard 7-point scale. Strong Republican, weak Republican, independent Republican, independent independent, independent Democrat, weak Democrat, strong Democrat. If I want to assess the reliability of the 7-point scale as a way of measuring party identification, I could ask you all the same question again at a later point in time. To the extent that your answers in the second round match your answers provided in the first round, the 7-point scale would be said to be a reliable way of measuring party identification. The test-retest method, it is important to note, can overestimate reliability. For example, you may remember the first answer you gave to the party identification question and answer the same way during the second round just to appear consistent, even if your actual party identification changed in the interim period. The test-retest method may also underestimate reliability, as when your party identification changes between the first and second rounds, and your answers at both stages reflect your actual party identification at that moment. A second way of assessing reliability is the split halves method. In the split halves method, the phenomenon is measured at a single point in time. This eliminates the possibility that the actual answer changes between rounds of measurement. To utilize the split halves method, the concept must be operationalized via a multi-item measure. For example, a person's political ideology might be measured through a series of 4 questions, asking their attitudes toward universal health insurance, the minimum wage, tax cuts, and defense spending. If individuals who respond in a liberal manner to the universal health insurance and minimum wage questions also respond liberally to the tax cut and defense spending questions, then the 4 questions together can be said to constitute a reliable multi-item measure of political ideology. Note that the split halves method hinges on the assumption that both components tap the underlying concept equally well. If this assumption is not met, then the whole method falls apart. The second way of gauging the accuracy and error of our measures is validity. Validity is the extent to which a measurement technique actually measures the phenomenon it is supposed to measure. Once again, there are a variety of ways of assessing validity that are discussed in the Johnson and Reynolds textbook. Rather than lay out all of these methods, we will focus on 2 in this presentation. The first method is face validity. Face validity is the extent to which a measurement technique seems to measure the phenomenon that it is supposed to, on the face of it. Note that face validity entails a subjective assessment on the part of the researcher. It is not an empirical assessment. This subjective assessment is considered to be a stronger claim to validity if a consensus exists among experts in the field. For example, there is widespread agreement among pollsters and political scientists that the 7-point scale is a valid way of measuring party identification. A second way of assessing validity is construct validity. Construct validity is the extent to which a measure is related to measures of other variables in ways that are hypothesized. Let's say that we hypothesize that human rights abuses occur with less frequency as the level of democracy in countries increases. Our measures of human rights abuses and level of democracy would be said to have construct validity if indeed it turned out that countries with higher levels of democracy did experience fewer human rights abuses. Note that construct validity assumes that we have correctly specified the nature of the association between the variables in question. In other words, one reason why our measures of democracy and human rights might not be associated with one another is that democracies are not better than other types of political systems in protecting human rights. Our measures of democracy and human rights might be accurate, but our incorrect hypothesis leads us to conclude that the measures do not possess construct validity. Before wrapping up this presentation, I want to note one more thing about reliability and validity, specifically regarding the relationship between these 2 standards for assessing the accuracy and error of measures. Note that reliable measures can be invalid. For example, I can step onto a scale multiple times and always get the same weight. But what if this weight is incorrect? Such a scale would be reliable, but not valid. Also note that valid measures are necessarily reliable. That is, if a measure accurately taps the underlying phenomenon, then it must by definition do so across repeat measurements.
Now let's explore the processing of research data. By the time we get to the analysis of data, most of the really difficult work has been done. It is much more difficult to define the research problem, develop and implement a sampling plan, conceptualize, operationalize and test their measures, and develop a design structure. If we have done this work well, the analysis of the data is usually a fairly straightforward affair. In most social research, the data analysis involves three major steps, done in roughly this order: cleaning and organizing the data for analysis, data preparation, describing the data, descriptive statistics, testing hypotheses and models, inferential statistics, interpretation and analysis. Analyzing survey data is an important and exciting step in the survey process. It is the time that we may reveal important facts about customers, uncover trends that might not have otherwise have known existed, or provide irrefutable facts to support our plans. By doing in-depth data comparisons, we can begin to identify relationships between various data that will help them understand more about their respondents and guide towards better decisions. Editing. The process of checking and adjusting responses in the completed questionnaires for omissions, legibility, and consistency, and readying them for coding and storage. Fieldwork often produces data containing mistakes. Coding. Editing may be differentiated from coding, which is the assignment of numerical scores or classifying symbols to previously edited data. Careful editing makes the coding job easier. Codes are meant to represent the meaning in the data. Assigning numerical symbols permits the transfer of data from questionnaires or interview forms to a computer. Codes often, but not always, are numerical symbols. Classification of data. Corner defined classification as the process of arranging things in groups or classes according to their resemblances and affinities, and gives expression to the unity of attributes that may subsist amongst a diversity of individuals. The raw data collected in real situations and arranged haphazardly do not give a clear picture. Thus, to locate similarities and reduce mental strain, we resort to classification. Classification condenses the data by dropping out unnecessary details. It facilitates comparison between different sets of data, clearly showing the different points of agreement and disagreement. It enables us to study the relationship between several characteristics and make further statistical treatment like tabulation, etc. Primary rules of classification. In quantitative classification, we classify data by assigning arbitrary limits called class limits. The group between any two class limits is termed as class or class interval. The primary rules of classifications are given below. There should not be any ambiguity in the definition of classes. It will eliminate all doubts while including a particular item in a class. All the classes should preferably have equal width or length. Only in some special cases we use classes of unequal width. The class limits, integral or fractional, should be selected in such a way that no value of the item in the raw data coincides with the value of the limit. The number of classes should preferably be between 10 and 20, that is neither too large nor too small. The classes should be exhaustive, that is, each value of the raw data should be included in them. The classes should be mutually exclusive and non-overlapping, that is, each item of the raw data should fit only in one class. The classification must be suitable for the object of inquiry. The classification should be flexible and items included in each class must be homogeneous. Width of class interval is determined by first fixing the number of class intervals and then dividing the total range by that number. Modes of classification. There are 4 modes of classification: qualitative, quantitative, temporal, and spatial. Tabulation of data. Tabulation is another way of summarizing and presenting the given data in a systematic form in rows and columns. Such presentation facilitates comparisons by bringing related information close to each other and helps in further statistical analysis and interpretation. Parts of a table. Table number. A table should be numbered for easy identification and reference in future. The table number may be given either in the center or the side of the table, but above the top of the title of the table. Title of the table. Each table must have a brief, self-explanatory and complete title which can indicate the nature of the data contained. It can explain the locality, that is geographical or physical, of data covered. It can indicate the time or the period of data obtained. And it can contain the source of the data to indicate the authority for the data as a means of verification and as a reference. The source is always placed below the table. Caption and stubs. The headings for columns and rows are called captions and stub respectively. They must be clear and concise. Body. The body of the table should contain the numerical information. The numerical information is arranged according to the descriptions given for each column and for each row. Prefatory or head note. If needed, a prefatory note is given just below the title for its further description in a prominent type. It is usually enclosed in brackets and is about the unit of measurement. Footnotes. Anything written in table is called a footnote. It is written to further clarify either the title captions or the stubs. Types of table. The classification of tables depend on the various aspects: objective and scope of investigation, the nature of data, primary or secondary for investigation, extent of data coverage, and so on. Simple and complex tables. In a simple table, also known as one-way table, data are presented based on only one characteristic. In a complex table, also known as a manifold table, data is represented according to two or more characteristics simultaneously. The complex tables are a two-way or a three-way tables according to whether two or three characteristics are presented simultaneously. Double or two-way table. In such a table, the variable under study is further subdivided into two groups according to two interrelated characteristics. Three-way table. In such a table, the variable under study is divided according to three interrelated characteristics. Manifold or higher order table. Such tables provide information about a large number of interrelated characteristics in the data set. Original and derived tables. Original tables are also called classification tables. Such a table contains data collected from a primary source. Let's move on to the topic application of computers in processing and analysis of data. It is concerned with abstracting information from large volumes of data. Business data processing (BDP) is a major application of computer where huge quantity of data forms the input for processing the results in collapsing data into a small quantity of meaningful information to users. For processing the large amount of data, human capabilities fall short. Therefore, computers are used to process these types of data. COBOL, a programming language, was used in 1960s for business data processing. Thus, data processing is the execution of systematic sequence of operations upon data to transform it into information. Data processing involves a number of transactions and file maintenance in order to provide a database for generating and providing information to users at management levels. Computers are used to make these transactions and processing simpler. However, there is a proper procedure that is adopted to generate the desired results. Following is the process for data processing. Identify the data, designing forms, entering data, validation storage, processing data, generating the reports. Computer structures the data in the form of vouchers, etc. It stores the data for further processing. Now in the end, let us summarize what we have learned in this lecture. Scaling is the branch of measurement that involves the construction of an instrument that associates qualitative constructs with quantitative metric units. Reliability has to do with the quality of measurement. In its everyday sense, reliability is the consistency or repeatability of measures. Data preparation involves checking or logging the data in, checking the data for accuracy, entering the data into the computer, transforming the data, and developing and documenting a database structure that integrates the various measures. Descriptive statistics are used to describe the basic features of the data in a study. Scaling is the branch of measurement that involves the construction of an instrument that associates qualitative constructs with quantitative metric units.